Hello everyone. So previously we had discussed on the topic monotonic stack, right? So today we'll be discussing on the algorithm or on the topic basically monotonic queue algo, right? So let's get into the definition part. Let's see what the definition part says here, right? So a monotonic queue is a special type of queue that maintains its elements on the either increasing or the decreasing order. Just keep this in mind. A monotonic queue is a special type of queue that maintain its elements on either increasing or the decreasing order. It allows us to efficiently find the minimum or the maximum values on a sliding window over an array. Again, what it does, it allows us to efficiently find the minimum or maximum values on a sliding window over an array, right? In a sliding window over the array, right? So this is fine, I believe. Let's get into the explanation part here. So just listen to this carefully, because we'll be doing the same thing, or we'll be implementing the same thing in the form of algorithm or the code by making use of the this one Python programming language, right? So this is fine. So first what we are doing here, let's imagine if we want to find the maximum in every sliding window of the size k in an array, right? Just imagine, suppose if we want to find the maximum element on the every sliding window of size k, right? Size of particular this one, let's consider k in the array, right? So if we just check all the k elements for every window, if we are just checking all the k elements for every window, it would be slow, right? It would be slow. It would take big of n into k. So what does the monotonic queue does here? Monotonic queue stores the elements in the way that the front always has the answer, max or minimum, maximum or the minimum. So this is important. This one is very important. Again, a monotonic queue stores the elements in a way that the front always has the answer, maximum or the minimum. And this one what do we call, and useless elements are removed as the new comes in, right? And what it does, and useless elements are removed as the new ones come in, right? So this is very important, right? So again, a monotonic queue stores elements in a way that the front always has the answer, maximum or the minimum, and useless elements are removed as new ones come in, right? So this is important, right? So this is fine. So let's move on with the operations part. So we have push, pop, max or min. This one push, what we are doing, so we will be inserting x but removing the smaller elements, right? So this is for the maximum queue, right? So we will be inserting x but removing the smaller elements. For the pop, we remove x if it's at the front of the queue. If it is at the front of the queue, we'll be removing x. And finally min, this one max or min, so basically we'll be returning the element at the front, right? So this is fine, I believe. So this makes the sliding window problems efficient on big of 1. So this is the time complexity big of n, right? So this is fine, I believe. Now let's try to implement the same thing whatever we discussed in the form of algorithm or the code, right? So first let's go with this one monotonic queue. This one, what do we call, let's go with some example, monotonic queue example, right? So let's consider sliding window maximum. For I'll just go with from, so why did this and take, what is happening? Oh, this is very slow, man. I don't know. I'll just go with the from collections here. So let me go with import dq, right? So this is fine. Now let me go with class monotonic. We are going with a monotonic queue, right? So yep, this is fine, man. So within this particular class, let's initially let's go with the initialization def init. Yep. So this one I'll just give self dot queue is nothing but, let's call the dq here. Let's, yep, dq. This is fine. Now let's do one thing. Let's go with a push method, right? Push function or the push method. So I'll just go with here def push. So this is nothing but self comma x. This is fine. The next part would be, while the last element is smaller than x, we have to remove it, right? So I'll just go with a while loop here. So this one will be self dot q, and this one self dot q of -1. So this one, if it is less than x, then I'll just go with a self dot q dot pop, right? So this is fine. And we have to add the new element. So let me do one thing. I'll just go with self dot q dot append of x. This is fine, man. Now let's do one thing. Let me go with a def max of, let me pass self here. This is fine. So let's go with the front of dq that holds the maximum. So in short term, in simple terms, I'll just go with a self dot q of 0 basically, right? So self basically q of 0 we have to consider. This is fine, man. Now let's go with a, we have went with a push, we have went with a max. Next, what is left? Pop is left basically, right? So if front equals the outgoing element, then we have to remove it, right? So first let me consider the method pop here, def pop pop. So this one be, we need the one more parameter, nothing but x here, right? If front equals the outgoing element, then we have to remove it in simple terms. So I'll just go with q and this one q of 0. If this is equivalent to the x, then what we need to do, I'll just go with pop left, right? So this one pop left, right? So this is fine, man. Now let's do one thing. Let's go with the sliding window max, man. So I'll just go with def sliding window. So this is max. Let me pass nums and k, right? So this is fine. So I'll just go with mq. So this one nothing but the monotonic q. So let me call here monotonic q class basically. This is fine. So also we need the resulting variable, right? So I'll just go with res and let me initialize this one to the empty array. So first what we need to do, basically here we have to process first k element. So let's go with the iteration here for I in range within the k, right? So we are going with the sliding window function basically. So this one we have to consider range within k. So this one monotonic q. So let's make use of the push. We have already written push. So this one will be nums of I. Simple, right? Now we have to append, what we have to append basically maximum, right? So this one will be monotonic q dot max. Yep. We have to append this one to the result variable. So this is fine. Yep, we are done with this part. Now we have to do this one. We have to process the remaining windows. So this one will be for I in range. So this is fine. So this one will be k comma length of nums. This is also fine. And we have to push the new element, nothing but mq push. So this is fine. So this one will be nums of I. Yep. So we have just pushed the new element. Next what we'll do, we have to remove the outgoing element, right? So this one will be mq dot pop. So this one will be nums of I minus k. Yep. Final thing is we have to record the current max, nothing but result dot append. So this is fine. mq is nothing but the monotonic q dot max. So this is also fine, man. Yep. We are just recording the current max. We are done with the algo almost. So we are left with only one thing, that we have to return the result, right? So we have to return the result variable res. So this is fine. We are done with the monotonic q algorithm, right? So basically we have considered the example, monotonic q example itself for the sliding window maximum, right? You can just consider sliding window minimum as well. In this case, within the particular window of k, within the particular this one window of k, so we are we should be able to find the maximum. That's what we are doing here by making use of the monotonic q. Simple. You can go with a sliding window minimum as well. It's your wish, right? So let's go with the example run. So I insist you to go out with a this one minimum, so you get that algo as well, right? So it will be easier to implement if some problem is asked, right? So this is fine. So this one will be array of, I'll just consider some random numbers. This one will be 1 3. Let me consider negative numbers as well, -1 -3. I'll just go with some random numbers, 5 3 6 7, right? So this is fine, man. Now let's consider the window size as well. I'll just go with the window size. So this is equivalent to the let me go with 3, right? So let's consider 3 elements in the window. This is fine, right? So now let me go with the output and let me assign this one to the sliding window max, this one, right? So let me pass array, and let me go with the window size as well, this one. Yep, finally let's go with the print, this one, print. Let me pass the output here basically, right? So we are having we are going with a window size 3, right? Just give me a second. So we know the sliding window algorithm, right? So we have already discussed sliding window and 2 pointers algo, right? So this we know, this is easy one. So I'll just go with this one. Let me explain the example very quickly. We have considered this example. I've just considered some random numbers, right? So window size I have given 3. If I remove this one window size, I have given 3 here, right? So first 3 windows, 1, 3, minus 1. What is maximum? 3 among 1, 3, minus 1. Next we have to consider, leave the first this one element. Next 3 we have to consider 3 minus 1, minus 3, which is the maximum 3. Next we have to consider this one. Let's leave the first 2 elements. Now we'll be going with a minus 1, minus 3 and 5, which is the maximum one, basically 5, right? So this is fine, I believe. Minus 1, minus 3, 5, 5 is the maximum. Next let's go with the minus 3, 5 and 3. So which is the maximum? Again 5, right? So this is fine. Now let's leave the first 4 elements. Let's go with a 5, 3, 6 here. 5, 3, 6 among 5, 3, 6, which is maximum 6, right? So next let's leave the fifth element as well. The last window is here, this one, 3, 6, 7. Among the 3, 6, 7, which is the maximum? 7 is maximum. So output that we need to get here is this one. Within every window we have to calculate the maximum. So window size we have considered 3. So this one has to be 3, 3, 5, 5, 6, 7 has to be our output basically, right? So just remember what output that we need to get here: 3, 3, 5, 5, 6, 7, 3, 3, 5, 5, 6, 7, right? So this is fine. Let me delete this one. Let me do one thing. Let me give Control J here. Clear screen, right click, rename. Let me copy the file name. Let me do one thing. Let me give Python here, file name.py, enter. So see here, the output that we are getting here is 3, 3, 5, 5, 6, 7. So we are getting the desired output, meaning we have written the this one algorithm correctly basically, right? So in simple terms, let me explain what I have done here. So I have considered here class monotonic queue. Monotonic queue, basically it uses dequeue to efficiently maintain the order. Just remember this one. We have made use of the dequeue itself, right? See here, this one, line number 28. So monotonic queue uses dequeue to maintain the to efficiently maintain the order. So this one, push of x, whatever I have considered, this part, line number 30. So this method is that. So this one, what it does, it removes all the smaller elements at the back, since they'll never be max again, right? So this is fine. Next, let's move on with the max method, right? So max, what it does, it gives the current maximum and big of one time. This is fine. Next, let's move on with the pop method. So this removes the outgoing element if it is at the front, right? So this is also fine. Next, let's do one thing. Let's go with a sliding window max, right? So this one, sliding window max function, whatever I have written, so this processes the array, right? So we are processing the array by making use of the sliding window max, this one function or the helper method. So first, what it does, first it fills the queue with the first k elements. First it fills the queue with the first k elements, right? So then for each new element, it pushes it and pops the oldest. It pushes it and pops the oldest, right? So then it keeps the it keeps the track of the maximum after each window size, right? So this one, right? So this is fine, I believe. So this is what the algorithm does basically, whatever the code that we have written. So yep, for the input we have got the desired output 3, 3, 5, 5, 6, 7. So whatever the algorithm that we have written works absolutely correct. I have shown you each window, right? So we have got the desired output. So this is it about the monotonic queue algorithm, right? So let me summarize whatever we have learned so far. I'll just say or let me tell you one thing. Let's consider 3 or 4 points that's very important. Just try to remember this one, right? So what does the monotonic queue does here? A monotonic queue is a queue basically that maintains the elements in the sorted order. Again, what is monotonic queue here? A monotonic queue is a queue that maintains elements in the sorted order. So it enables the efficient sliding window maximum or the minimum queries in big of n. Again, what it does, it enables the efficient sliding window maximum or the minimum queries in big of n. So operations like push, pop and maximum or minimum run in the amortized big of 1 amortized because of 1, right? So operations like push, pop, max and min, whatever we have written here, push, pop, max and min. So what it does, we have went with a max for this particular one. We have went with a basically sliding window maximum. We are finding the maximum in every window, right? So we can go with a minimum as well. So operations like push, pop and max or minimum run none amortized because of 1. Just try to remember this one, amortized because of 1, right? So this is fine. This is very helpful in the problems like sliding window maximum. We can use this one in the stock span as well, right? So we'll be solving that one. We have solved that one, right, using the greedy approach. And also we have made use of the monotonic queue, I believe, somewhere very recently in the context. Some contest I had made use of this one, monotonic queue, as well as the monotonic stack. So this is fine. It's very useful in problems like sliding window maximum, stock span and many range query scenarios, right? So this is fine, I believe. So this is it for the monotonic queue algorithm. So we are done with the algoritamic part, right? So now this is it for this one, monotonic queue algorithm. So next what we'll be doing, we'll be discussing tomorrow we'll be discussing on the expression evaluation algorithm, right? So this is also related to the stack and queue algorithms, right? So next we'll be discussing on the topic expression evaluation algorithm, right? For now this is it. Thanks for watching, guys.